Welcome to math classes. Today we will see some critical questions from limits and differentiation, mainly PYQs from JEE and BITSAT and some preparation questions. Okay, so let's get into the questions now. Yeah, the first one is if g of x is a linear function. Okay, note down this one. G of x is a linear function and f of x is defined as g of x for x less than or equal to 0 and f of x is defined as 1 plus x divided by 2 plus x whole to the power of 1 by x for x greater than 0. And this is continuous at x equal to 0. Okay, and if f dash 1 equal to f of minus 1, then what is the value of g of 3? Okay, it's a big question, but let's take step by step actually. Okay, first thing is given is g of x is a linear function, correct? So let's complete the definition of f of x. Okay, because one part of it has f of x equal to g of x, correct? So g of x is nothing but linear function, so it is, I can assume it as ax plus b. Okay, it is in this form only. Okay, now it is also given that f of x is continuous at x equal to 0, correct? So if f of x is continuous at x equal to 0, which means limit of this value, okay, is equal to limit of this value, that is limit of 0 minus is equal to limit of x tends to 0 plus, which is equal to f of 0, correct? So I will use this one. F of 0 is nothing but g of 0, because this is definition for x less than or equal to 0, correct? Okay, now limit x tends to 0 plus, I have to use this one because x greater than 0, this is the definition, right? So limit x tends to 0 plus, okay, 1 plus x divided by 2 plus x whole to the power of 1 by x, which is equal to f of 0, which is nothing but g of 0, which is, if I substitute g of 0, it is nothing but b, correct? Ax will become 0, right? So this is my b value. Okay, let's find out what is this value. This value is nothing but actually, okay, if I take x is tending to 0, so this will become 1 by 2 whole to the power of infinity. Infinity is very large number, so decimal to the power of very large number is nothing but 0, it will tend to 0. Okay, so my b is nothing but 0, correct? B is equal to 0, so my g of x is nothing but ax. Okay, and f of minus 1 is nothing but minus a. Okay, f of minus 1 comes from this one, right? F of minus 1 is nothing but g of minus 1. G of minus 1 is minus a, correct? So once you know this one, this definition, now let's find out what is f dash 1. Okay, so for f dash 1, we need to find out f dash x first. Okay, so f dash x, we have to take this value. Okay, because we are interested in 1, f dash of 1. So x is greater than 0, which means I need to take this definition, correct? So f of x equal to this. Now when you have a function defined in g of x to the power of h of x and you want a derivation, then you will use logarithm, correct? So I applied logarithm here on both sides. So log of f of x equal to 1 by x to the power of log of this value, which is nothing but 1 by x into log of 1 plus x minus log of 2 plus x. Okay, so if I differentiate now, this will become 1 by f of x into f dash x, which is equal to this value. Okay, differentiation of this expression here. Okay, now my f dash x is nothing but this value. Okay, because f of x I am taking to the other side, so it is here. Now what I need is f dash of 1 only, correct? So I don't want to simplify this one, I just substitute 1. My f dash 1 is nothing but minus 1 log 2 by 3 plus 1 by 6 into 2 by 3. This is my f dash of 1, which is nothing but f of minus 1. So f of minus 1 is minus a. So this is my minus a. So my a will be just you change the sign here. Okay, this will become minus 1 by 6. Log 2 by 3 minus 1 by 6 into 2 by 3 it will become. Okay, so now what is my g of 3? G of 3 is nothing but 3a, correct? G of 3 is nothing but 3a. So 3a is, okay, 3a is 2 times log 2 by 3 minus 1 by 6. Okay, this is the answer. Okay, hope you understand. This involves actually limits, derivation, functions, and several things. Okay, so you can expect such questions in JEE mains and advanced more. Okay, where you have combined information, you require combined knowledge of the chapters. Okay, so next, if g of x denotes the greatest integer function, then find the value of limit n tends to infinity g of x plus g of 2x plus g of 3x up to g of nx divided by n square. Okay, so let's do this one. So first thing is, whenever you find gif, actually you need to find a replacement. Okay, how I can replace these terms, that is most important. Okay, so here I will try to apply the sandwich theorem to solve the problem. Normally we know that sandwich theorem is only till we know how to get some standard derivations or standard limits basically, correct? But you can actually use them to solve problems. Let's do this. Okay, so we know that uh, GIF of nx mainly depends on x. It is difficult to guess the value of expression, correct? So we know that GIF of x is between x minus 1 and x. GIF of 2x is between 2x minus 1 and 2x. Similarly, GIF of n minus x is between n minus x and nx, correct? So now you add all these things, all these inequalities you add. What you will get is, okay, what you will get is x plus 2x plus 3x up to nx minus n, because this minus 1 is n times, okay, which is less than or equal to GIF of x plus GIF of 2x plus up to GIF of nx. So this is what numerator I got now, okay, which is less than or equal to x plus 2x plus 3x up to nx. Okay, now we know that I am representing GIF of x values in terms of other values, right? Now I apply divided by n square and apply limit basically. Okay, so this will become limit n tends to infinity, this x plus 2x up to nx minus n divided by n square less than or equal to, this is the value which we want to find out, less than or equal to limit n tends to infinity x plus 2x up to nx divided by n square. Now this is simple. Okay, this is nothing but n into n plus 1 by 2 into x minus n divided by n square. Okay, and this value is n into n plus 1 by n square, okay, into x, okay, n into n plus 1 by 2 into x by n square. Okay, now this value is nothing but, okay, if I take n square inside, actually only x by 2 is the value I'll get, because I have to, n is tending to infinity, so I will try to get all 1 by n terms. Okay, so if I take n square common from this one, I will have x by 2 plus 1 by n minus 1 by n. So my plus 1 by n minus 1 by n are plus x by n minus 1 by n will become zeros because they have 1 by n terms. Okay, so I'm left with x by 2 here. Okay, similarly on the RHS side also, if I divide, I am left with x by 2 only. Okay, so n square is 1 by 2 into x, which is x by 2, and here I am left with 1 by x by n, which is nothing but 0. Okay, so by sandwich theorem, you know that if you have a limit between two equal values, right? Okay, if x by 2 less than or equal to limit n tends to infinity, this definition less than or equal to x by 2, which means this limit value also should be equal to x by 2, correct? So this is what x by 2. Okay, now we solve this problem using sandwich theorem. So don't ignore sandwich theorem. Applications are useful. I think we have some problems from JEE advanced on sandwich theorem. Okay, next. Limit x tends to infinity, square root of x square minus square root of x square minus square root of x square infinite times divided by x equal to how much? Okay, so whether this problem comes in the number theory or polynomials, wherever, we know how to solve it. We always take it as a function of x. The infinite series we convert into function of x. Okay, same thing we'll do here. Okay, and apply sandwich theorem. Let's do how to do this. F of x is defined as this one, numerator. Okay, then f of x is equal to square root of x square minus f of x, because the second part also infinite series, so this is also equal to f of x, correct? This is the basic thing which we do in the number theory, right, for solving such infinite series problems. Okay, so now square it on both sides, what you will get is f of x whole square equal to x square minus f of x, or f of x whole square plus f of x equal to x square. Now let's convert this into a square, okay, perfect square. Okay, how to do that? I can add some term here, numerator term here, because this is, let's say, a square plus a I have. So if I add 1 by 2 whole square on both sides, then I can make it into perfect square. Okay, that's what I'm trying to do it here. So f of x whole square plus f of x plus 1 by 4 equal to x square plus 1 by 4, or I can call this LHL as f of x plus 1 by 2 whole square equal to x square plus 1 by 4. Okay, now all I need is f of x by x and then limit apply, right? So if I apply square root of this one, okay, divided by x and apply limit, that's what I get, correct? So let's do that. Okay, so we know that one more thing is, okay, this is a square and this is equal to x square plus 1 by 4. So that means this is between, this function is between x square and x square plus 1 by 4, correct? I can write this. Okay, now once you know this one, okay, Okay, here also it's greater than or equal to. Okay, let us apply square root divided with x and limit. Apply limit. All three we do. This is what I'll get. Okay, so limit x tends to infinity x by x, because it is x square by square root of x square, which is x, and divided with x, so divided with x. Okay, then less than or equal to limit x tends to infinity f of x plus 1 by 2 divided by x, less than or equal to limit x tends to infinity square root of x square plus 1 by 4 divided by x. Okay, so I know that this is 1. Simple. So 1. Okay, and what about this one? Okay, this also, if I take this x inside, okay, it will become 1 plus 1 by 4x square. Since x is tending to infinity, 1 by x 4x square will become 0. So this is nothing but square root of 1, which is 1. Okay, so the limit f of x plus 1 by 2 plus divided by x is between 1 and 1, which means this is nothing but this is 1. Correct? By sandwich theorem. Now this is 1, I know. Now I separate this f of x by x. Okay, limit x tends to infinity f of x by x, which is what I am looking at. What is the value I want to know? Okay, and limit x tends to infinity half by x. Okay, half by x is 0, it will become, because this is 1 by x. X is tending to infinity, 1 by x will become 0. So this is 0, which means which one is 1? 1 is only this value. Okay, this value is the 1. Okay, so that is what I am looking at. The limit x tends to infinity square root of x square minus square root of x square, infinite series divided by x is nothing but 1. Okay, next. Okay, you can also solve at this point actually. At this point you can take f of x square plus fx minus x square equal to 0 and apply quadratic formula. You can solve that way also, but same thing, you have to apply sandwich theorem. Okay, next. The function f defined from a real to real as limit n tends to infinity. Okay, note down this one. This is not x tends to infinity. This is n tends to infinity. Cos 2 pi x minus x to the power of 2n sine x minus n divided by 1 plus x to the power of 2n plus 1 minus x to the power of 2n is continuous for all x in. Okay, and options are given, which means he's asking which points it is discontinuous. Okay, so one way to solve this problem is you just find out there are only 3 points which are given here, right? 1, -1 and 0. You directly find out whether at these 3 points it is continuous or discontinuous, and then assume that remaining all are anyway continuous, because if you look at the options, it is always r minus these points. Correct? Otherwise, just find out the general way. Okay, let's do the general way, but you can solve it other way also. Okay, let us consider the limit by different values of x first. Okay, so x can be, one is modulus of x can be greater than 1, less than 1, and then equal to 1. Correct? These three conditions will take. First thing is modulus of x is less than 1, which means x is between -1 and 1. Okay, in this case what happens is, as n tends to infinity, okay, x is less than 1, okay, and less than 1 value, that is decimal value to the power of infinity, will become 0. Okay, so which means this term x to the power of 2n plus 1, all this will become 0. So I am left with cos 2 pi x. Correct? Cos 2 pi x divided by 1. This is my f of x. Okay, now I know that this is a continuous function. Correct? Cos is a continuous function, so this is a continuous function. Fine. So now for x modulus x less than 1, I am done. Let's take modulus of x greater than 1, which means what I am covering, minus infinity to -1 and 1 to infinity. Okay, not 0. Okay, remember, not between -1 and 1. Okay, so yeah, this is as n tends to infinity, x to the power of 2n, because x is now greater than 1, will become infinity. So what I need to do, I need to take x to the power of 2n common from numerator denominator and then cancel them. Correct? That's what I do. So if I take x to the power of 2n common, this will become cos of 2 pi x divided by x to the power of 2n minus sine of x minus 1 divided by x to the power of 2n into 1 by x to the power of 2n plus x minus 1. Now these two gets cancelled. So I am left with, if I apply limit, I am left with this is 0, this is 0, minus sine of x minus 1 divided by x minus 1. Correct? So my limit is nothing but limit n tends to infinity f of x is equal to minus sine of x minus 1 by x minus 1. Okay, this is my limit. Since x is not equal to 1 in this case, this limit is always exists. This limit always exists because x is not equal to 1. Okay, here x is greater than 1. Okay, right? So this is also continuous for all modulus x greater than 1. Okay, now next, and not for definitely x equal to 1, because that is not part of this domain. Okay, that comes next. Okay, so now next take the remaining two cases, which is x equal to 1 and x equal to -1. Correct? So x equal to 1, x equal to 1, if I substitute, this whole function will become just cos 2 pi, which is nothing but 1. Correct? Now, I need to just apply limit n tends to infinity and see what happens. Correct? Okay. So, if the limit exists or not. Okay. He mentioned it is continuous for all x. So, now let me find out x tends to 1 plus and x tends to 1 minus. That is RHL and LHL. Let me find out. Okay. So, first is RHL. RHL is nothing but 1 plus if it becomes, okay, 1 plus if it becomes greater than 1, right? X is greater than 1, so I should take this definition. Okay, this is my definition. Okay, if I take this definition and apply limit x tends to 1 plus, okay, what I will have is this is nothing but minus 1. Correct? This is sin x by x form, sin x by x, and x tends to 0 form. Correct? So this is minus 1, this is RHL. Here itself we can see f of 1 is 1, but RHL is minus 1, so they are not equal, so it is not continuous, obviously. But you can also find your LHL. LHL is nothing but 2 pi x, correct? Because when x is between less than 1, I need to take this definition. Correct? So this definition, it is 1. So yeah, obviously it is clear that it is not equal, so it is not continuous at x equal to 1. Okay, similarly case 4, x equal to minus 1. Okay, x equal to minus 1, f of minus 1 is nothing but 1 plus sin 2. If I substitute, that's what I get, 1 plus sin 2. Okay, my LHL is nothing but sin 2 by 2, because if I take this definition, I'll get sin 2 by 2. Okay, so which is not equal already. Okay, so RHL also will get a different value. So limit is not continuous at x equal to minus 1 also. So answer is r minus 1 and minus 1. Correct? So option B is correct also. Yeah, next. Yeah, f of x is defined as modulus of 4x square minus 8x plus 5 if 8x square minus 6x plus 1 is greater than or equal to 0. It is defined as GIF of 4x square minus 8x plus 5 if 8x square minus 6x plus 1 is less than 0. The number of points in R where f of x is not differentiable is. Okay, so look at the definition of f of x. First thing is we need to simplify this one. Okay, first let's simplify the ranges. Okay, so 8x square minus 6x plus 1 is nothing but 2x minus 1 into 4x minus 1. Okay, which means if it is greater than or equal to 0, okay, x belongs to minus infinity to 1 by 4 union with 1 by 2 to infinity. Okay, so you know the range of if this is greater than or equal to 0. Correct? Now if it is less than or equal to 0, x belongs to 1 by 4 to 1 by 2. So this is the range. Second range also we found. So now let's redefine the function. Now function looks like this. Okay, modulus if x is belongs to this range, GIF function if x belongs to this range. Okay, now let us simplify this inside one. Okay, 4x square minus 8x plus 5. What is this one? Let's see. This is nothing but I can rewrite this as 2x square minus 2x into 2 plus 4 plus 1, so that I have a square actually. 2x minus 2 whole square plus 1. Okay, now we know that this is always positive in any range. Correct? 2x minus 2 is always positive because you have a plus 1 and some y square. Correct? So which is always positive. So obviously you don't need the modulus here. First thing. Correct? Okay. Next thing. G of x. Let's take g of x as this value. Now let's find out it is the increasing function or decreasing function. That will give us some information for the step function. Okay, or GIF function. Okay. So this is my g of x. My g dash x is nothing but 8x minus 8. Okay, now in the range 1 by 4 comma 1 by 2, in the range 1 by 4 comma 1 by 2, g dash x is always negative. Okay, you substitute and see, you will get negative, which means it is a decreasing function. Okay, now how is the decreasing function? Which means at the lower limit it will have a higher value than upper limit. Correct? G of g dash x will have higher value here at this limit than this. Correct? That is how decreasing function it is. Correct? So which means g of 1 by 4 is greater than g of 1 by 2. Okay, once you know this one, GIF of g of 1 by 4 is nothing but 3 you will get, and GIF of g of 1 by 2 is 2. Okay, which means you can clearly see there are two integral step values, right? Two step values for this GIF function. One is 3, one is 2. That means there are, you can break this into 1 by 4 comma alpha and 1 by 2 comma and alpha comma 1 by 2. Correct? You can define like this: f of x as 3 if it is x belongs to 1 by 4 comma alpha, and it is 2 if x belongs to alpha to 1 by 2. Alpha value doesn't is not important here, but if you want you can derive yourself actually from the above information that alpha is nothing but 2 minus square root of 2 by 2. You can derive easily, okay, but that's not important. Okay, now you have complete function definition. Let's see how the function is looking. The function is looking something like this. It has a modulus. You don't need to put modulus because it's always positive now, we know. Okay, so if x belongs to minus infinity to 1 by 4 union with 1 by 2 comma infinity, and it is 3 if it is 1 by 4 comma alpha, if it is 2 if it is alpha comma 1 by 2, correct? Now if I draw this a rough graph, how it looks is, first is you have a parabolic curved line, okay, and then at 1 by 4 there is a step, correct? Up to alpha there is a line, continuous line, and there is a jump, okay, and 1 by 4 we can substitute here and see actually what happens. If I substitute 1 by 4 here, what value I will get, based on that you can either connect or disconnect. Okay, this is not very important. Okay, now there is a jump to 2 and there is a continuous 2, okay, up to 1 by 2, correct? Alpha to 1 by 2 is, it is 2, and then again this function will continue 1 by 2 comma infinity, increasing like this. Okay, so now you know this is continuous. Sorry, we are looking at differentiable points. So there are 3 points where this is you find the jumps actually. This is 1 point, correct? This is second point, you have a jump, and this is the third point where you have a sharp edge here, jump here, sharp edge here. So these are the 3 points where this function is not differentiable, right? So this is how you need to solve such problems. Whenever you find modulus and GIF, be careful, redefine the function definition actually, then it will be easy to solve the problem. Okay, so 3 points it is not differentiable. Next, okay, f of x is defined as x square sine 1 by x if x is not equal to 0, and it is 0 if x equal to 0. Then continuity of f dash and differentiability of f dash x. Okay, you need to find 3 things: continuity of at f and f dash, differentiability at f dash x. Okay, so if f of 0 equal to 0, that's what is given. So limit x tends to 0, if I find the limit, okay, whether it is 0 plus or 0 minus, I have same definition, that is x square sine 1 by x. So I'm just finding limit x tends to 0. X square sine 1 by x is nothing but 0 into sine 1 by x. This is a sine function, okay, it oscillates between -1 and 1, I know, and multiplied by 0, so I'll always get 0. So f is continuous at x equal to 0. Fine. So that is one thing is we already found. Next, for finding the differentiability, LHD equal to limit of h tends to 0 minus f of 0 plus h minus f of 0 by h. By definition, this is of differentiation. Okay, so limit h tends to 0 minus 0 plus h is nothing but that means it is not equal to 0, right? So which means I need to take this definition, h square into sine 1 by h minus 0 by h. This is nothing but h, limit h tends to 0, h into sine of 1 by h. Okay, now this is equal to 0. This is not sine y by y. Okay, I can rewrite this as sine 1 by h by h by 1 by h I can write, right? But this is h tends to 0, not h tends to infinity. If it is h tends to infinity, this will become 1. Okay, but here h tends to 0, so this is nothing but 0, because this is the oscillating function. Into 0 you get 0. Okay, so LHD is 0. Similarly, RHD also you can do it yourself, you will get 0. Okay, so LHD equal to RHD, which is 0. Hence f of x is differentiable at x equal to 0. Now 2 things you found. Okay, now f dash x. So what is f dash x? F dash x is simply 2x sine 1 by x plus x square cos 1 by x into minus 1 by x square. Okay, if I simplify, this is what is f dash x. Okay, and this is for x not equal to 0, correct? Only this definition. Okay, okay, now limit x tends to 0 and this f dash x. Okay, if I substitute, okay, I will get this is oscillating function sine 1 by x, cos 1 by x also oscillating function, but here sine 1 by x is multiplied by 0, so I'll get 0 here. This term is 0. So I am left with cos only. Cos 1 by 0, this is the oscillating function. So you cannot determine the value of this one between -1 and 1, I know, but I cannot tell what is the value, which means it is not differentiable at f dash x. Okay, so f of x is continuous and differentiable, but f dash x is not continuous at x equal to 0. Not continuous, sorry, not differentiable also. Okay, if it is not continuous, it's not differentiable also, right? So that's the answer for this one. Next. Okay, now function is defined from domain 0 to 1 inclusive to R is a twice differentiable function in 0 comma 1 such that f of 0 is 3 and f of 1 equal to 5. Okay, if the line y equal to 2x plus 3 intersects the graph f at only two distinct points in 0 comma 1, then least number of points where x is in 0 to 1 at which f double dash x equal to 0 is, which means what you need to find it, f double dash x equal to 0 means you are finding roots, okay, number of points, right? Roots of f double dash x, zeros of f double dash x you are finding. Okay, so this is one thing in the range 0 comma 1. Okay, now what is my function? Function definition is not there actually, but it is a twice differentiable function and f of 0 is 3, f of 1 is 5, and this f of x intersects with this line, okay, in 0 comma 1, not inclusive, okay, right? 0 and 1 are not inclusive, but inside this there are 2 points, it is two distinct points it is intersecting. Okay, so just imagine you can solve it two ways actually. I'll just show you. Okay, first thing is, if I take a function, okay, if I take a function g of 0 which is f of x, g of x which is f of x minus this y, f of x minus this y, okay, then what I will get, if g of 0 is 0, which means I am trying to find out where this line is intersecting with f of x, correct? So let's go with that method. Okay, let's take g of x equal to f of x minus 2x plus 3. If g of x is 0, which means f of x equal to 2x plus 3, this is nothing but I'm trying to solve where the 2 points, the line intersecting with f of x, correct? Now, g of 1 is nothing but, g of 0 is nothing but, sorry, g of 0 is nothing but f of 0 minus, if I substitute 0, I will get 3 only, so minus 3, f of 0 minus 3, and f of 0 is given as 3, so this is nothing but 0, okay? So, which means 0 is the point where this line intersects with this line 2x plus 3, y equal to 2x plus 3 intersects with f of x. Okay. Similarly, g of 1 also is nothing but f of 1 minus 2 plus 3, which is 5. F of 1 is 5 given as 5, so it is 0. So this line actually not only intersects between 0 and 1, it is also intersecting in the endpoints. Okay, 0 and 1. This is a good information. That means this line actually intersecting with the f of x at 4 points, including 0 and 1. Correct? That is the most important thing you should know. Okay. So let the point of intersection between 0 and 1, let it be x equal to a and x equal to b. Okay. These two are different from 0 and 1. 0 and 1 are the endpoints. Okay. But this a comma b are within 0 and 1. 2 points where this line intersects with f of x. Okay. Now, at those points, f of a equal to 2a plus 1 and f of b equal to 2b plus 3. 2a plus 3 and 2b plus 3. Correct? And which means g of a equal to g of b is also 0 because both are equal. Correct? Which means g of x has total 4 distinct roots in 0 comma 1 inclusive. Correct? G of x has 4 distinct roots in 0 comma 1. 0 is a root, 1 is a root, at a comma b, which are 2 points also roots. Correct? Now, from Rolle's theorem, I can say that g dash x can have minimum of 3 zeros. Correct? Minus 1 basically. Okay? Always differentiation, g dash f dash x will have 1 less than f of x zeros. Okay? So, according to Rolle's theorem, g dash x will have 4 minus 1 zeros, that is 3 zeros in 0 comma 1. Okay? Now, what is g dash x? G dash x is nothing but f dash x minus 2. Correct? This 3 is a constant, so it will become 0. Now, similarly, g double dash x will have 1 less zeros, right? So, 3 minus 1, that is 2 zeros in 0 comma 1. Okay? And what is g double dash x? G double dash x is nothing but f double dash x, which means f double dash x also will have 2 zeros in 0 comma 1. Okay, there. So least number of points is 2, minimum 2 points where f double dash x equal to 0. Correct? So is same as f double dash x. It has at least 2 points in 0 comma 1 where f double dash x equal to 0. Okay. So this is one way. Second way is, now you understood how my function is g g of x is, okay, g of x is intersecting y equal to, sorry, my f of x is nothing but intersecting with this line at 0 comma 1 and 2 more points inside. So correct, my graph, f of x graph looks something like this. Okay, the line is 2x plus 3, y equal to 2x plus 3 is here, and it intersects at y axis at 0 comma 3 and at 1 comma 5. Correct, this is my 2x plus 3. Now the graph f of x is something like this. Okay, this is the only way this graph has to be, otherwise it cannot have two intermediate points where it is intersecting with the line. Okay, now this is my f of x. What is f dash x? F dash x is nothing but derivation of this curve or tangent of this curve by making f dash x equal to 0. Okay, I will find zeros of f dash x. And what is f dash x equal to 0 means the slope of the tangent is 0. And how many such slopes I can find? I can find actually 3. Correct? Slope of tangent is 0, and I can find 3 slopes such a way that they are parallel to x-axis, which means slope of these tangents are equal to 0 at 3 points for f of x. Okay, which means f dash x has 3 zeros. Okay, once I know this one, according to Rolle's theorem, f double dash x will have 2 zeros. Correct, minimum 2 zeros. So the answer is 2, at least 2 points where f double dash x equal to 0. So these are the 2 ways you can solve this problem. Yeah, both require some analysis actually of how the function is looks like. You need to imagine actually from the given data. Yeah, next. These are the problems I choose, critical problems for limits and derivation. Very interesting problems. So keep doing your maths. I'll come up with more videos and more problems. Thank you.